And I'll just get myself full screen. There we go. Okay, so firstly, the mass of an African elephant is on average 12,000 pounds. What is this in standard form? So to do this, excuse me, what I'm going to do first is write down 12,000, and I'm going to consider how far the decimal would have to go from after the 1, okay, the first significant figure. So it would need to go 1, 2, 3, excuse me, 4 places. So that's going to be 1.2 times 10 to the power of 4. So that's how you'd write it in standard form. You all okay with that? Okay, so that's fairly straightforward. Now let's have a look at what we wanted to do today, which was adding in standard form. So if I just go down here, this is just basically how we would do it, 1.2 times 10 to the 4. Mass of a grain of sand, it would be the same sort of thing, but you need a minus because this is very small, okay, not a big number. Right, that's fine. I'm not worried about the GCSE questions here. For some reason it's just stopped. Let me just get this up. It's here. And I'll open it this way. There we go. Okay, so let's have a look here. I don't think we've really done much of this, writing standard form numbers as regular numbers. Hello, Ethan, okay. So if I want to write this as a regular number, so I've got 6.4 times 10 to the 3. If I want to write that as a regular number, all I would need to do is move the decimal point 3 places to the right, because I'm timesing by 10 3 times. So that's going to give me this number here. 1, 2, 3. And underneath these hoops, I'm going to put zeros. So I have 6400, and the decimal is now here. So that's the end. So we basically have 6,400. We all happy with that? Okay, right, so I think that one's fine. We'll leave that. We'll leave that one. Right, we've done multiplication yesterday, so I'm not worried about that really. Right, division. We basically did division yesterday as well. That's fine. Leave the GCSE questions for now. Right, here we go. We'll do adding and subtracting, okay, in standard form. So I'm going to make a nicer example first. So if you want to write this example down, this will be a good one to write down. So we're going to do, I'll do 2.3 times 10 to the 4 plus 3.8 times 10 to the 3. So can you write down that question? We're going to calculate what this is, okay? So the first thing we'll do it without a calculator, okay? Okay, so if you've managed to write that down, we'll have a look at how we can add this, okay? But before we do that, imagine that you've got 10 to the 3 plus 10 to the 3. If I had 10 to the 3 plus 10 to the 3, what would that give me? Well, 10 to the 3 plus 10 to the 3 is just going to be 2 lots of 10 to the 3, okay? So the point is, if you want to add up powers of 10, the actual power of 10 has to be the same, okay? Because if I had 10 to the 2 plus 10 to the 3, you can't add them up yet, okay? You wouldn't get 2 times 10 to the 3. You wouldn't get that. You need to make the powers of 10 the same. So we'll do that to do this question. So our method, whenever we add or take away in standard form, is to make the powers of 10 the same. So make powers the same. So here I've got 2.3 times 10 to the 4, 3.8 times 10 to the 3. Now, let's just say I want to make the 10 to the 3 here into a 10 to the 4. Okay, let's just do that. So to make 10 to the 3 into 10 to the 4, we would have to times, well, it's a different color, you would have to times the 10 to the 3 by 10. So what would you have to do to the 3.8 to keep everything balanced? I'm timesing one part of the number by 10. To keep it balanced, I would have to divide the other part of the number by 10, because that way you haven't actually times by anything. So we end up with 2.3 times 10 to the 4, that hasn't changed, plus 0.38 times 10 to the 4. Okay, so the idea is we're changing a 10 to the 3 to a 10 to the 4 by times it by 10, and we divide the number part by 10 to balance it. So we have 2.3 times 10 to the 4 plus 0.38 times 10 to the 4. The 10 to the 4s are the same, so we just need to add the decimal parts. So I have 2.3 plus 0.38, which is going to be 2.68. So I end up with 2.68 times 10 to the 4. Okay, so we will do more of those because it's not the easiest thing, but we will do some more of those to make sure we're happy. Okay. Okay, so let's look at another one just to make sure we're happy with that, and I'll put this into the chat as well, so you can have it there to refer to. Right, let's do another one of these. Right, so let's say I wanted to do 4.5 times 10 to the 3 plus, and I will say 2.4 times 10 to the 2. Okay. Right. Oh, sugar. There you go. Right. So why can't I just add these up straight away? What would I need to do to the powers of 10 so that I could add these numbers up? Oh, sorry, someone just messaged me. Right, we'd need to make the powers of 10 the same. So what we could do, if we wanted to, we could make the 10 to the 2 into a 10 to the 3. So what would I need to multiply 10 to the 2 by to get 10 to the 3? Well, that would just be 10. But if I times, and I'm just timesing this number, it's 2.4 times 10 to the 2. If I times it by 10, to keep it balanced, I would have to divide it by 10 as well, and then everything will be balanced. So I have 4.5 times 10 to the 3 plus, and then 2.4 divided by 10 is 0.24. So I've got 0.24 times 10 to the 3. And then I can add them up. I've got 4.5 times 10 to the 3 plus 0.24 times 10 to the 3. 4.5 plus 0.24 is 4.74. So it's 4.74 times 10 to the 3. Okay, so are we happy? We're just changing one of the powers of 10 so that both of the powers of 10 are the same. Is that okay? Right, let me go back to this. So there's some examples here. So, excuse me, everyone. So if I look at this one here, again, I want the powers of 10 the same. So I could take this 10 to the 4 and times by 10. But then if I times 10 to the 4 by 10, so I'm timesing this whole number by 10, I would need to divide the other part of the number by 10 to keep it balanced. So I would have 4.06 times 10 to the 5 plus 0.38 times 10 to the 5, 4.06 plus 0.38, let's do that. 14, you'd have 4.44. So you've got 4.44 times 10 to the 5, okay? And yeah, we have a corner, good. Okay, any ideas how we would do the second one? So 4.72 times 10 to the minus 2, take away 5.83 times 10 to the minus 3. Any ideas what we'd have to do here? It's the same method again. Think about what you have to add to minus 3 to get to minus 2. Well, minus 3, if you add 1, you get to minus 2. So you could times 10 to the minus 3 by 10, and then you would have to divide 5.83 by 10. So you would have 4.72 times 10 to the minus 2, take away 0.583 times 10 to the minus 2, and then you just have to take away. So 4.72, take away 0.583, which gives you 4.137, and that's times 10 to the minus 2. So I can see what you're doing there, Ethan. Yeah. So we have to times the 10 to the minus 3 by 10. And then the number part, 5.83 divided by 10. Yeah, and the idea is, as you said, so they both become minus 2. Brilliant. Because the powers of 10 have got to be the same before we add or take away. Very good. So let me give you a few questions to do. There we go. So there's questions A, B, and C. There we go. Okay, so we have these questions here. So there's, well, they both got B on for some reason. A, B, and then C. Okay, so have a go at these questions. I'll put a timer up now. If you are stuck, just let me know, and we will go over the answers shortly. There we go. So have a go at the questions on the screen now. And if you are stuck, just let me know. I need to answer someone's question on Teams as well, so I am here. I just need to answer this. Okay, so we'll have a look at the first one. So I've got 2.3 times 10 to the 3. I'll just write the workings on actually. And 6.4 times 10 to the 4. So it's up to you if you change the 3 into a 4 or the 4 into a 3. If I change the if I change the 10 to the 3 into a 10 to the 4, I'd have to times it by 10. And then I would have to divide the 2.3 by 10 to keep it balanced. So let's see what we'd end up with. So 2.3 divided by 10, that's 0.23. 10 to the 3 times 10, that is 10 to the 4. So I've got 0.23 times 10 to the 4 plus 6.4 times 10 to the 4. And all you've got to do now is 6.4 plus 0.23 and then put times 10 to the 4. So we have 6.63, that's dodgy right then, 6.63 times 10 to the 4. You all okay with that? Has anyone got an answer for B? So 5 times 10 to the 8 plus 6.8 times 10 to the 9? Or has anyone got an idea of what we could do? Yeah, brilliant. Well done, Ethan. That's really good. So we would times 10 to the 8 by 10 and then divide the 5 by 10. Brilliant. Because that would give you 0.5 times 10 to the 9. Yeah, that's brilliant. And then the powers of 10 are the same. So you've got plus 6.8 times 10 to the 9. So you've got 0.5 plus 6.8, which is 7.3. So you have 7.3 times 10 to the 9. And you know it's in standard form because 7.3 is between 1 and 10. So we can leave it like that. Then for the second one, or the last one, 9.2 times 10 to the 5, take away 3 times 10 to the 4. So for this one, we could times 10 to the 4 by 10, divide 3 by 10. So we have 9.2 times 10 to the 5, take away 0.3 times 10 to the 5, which will give you 8.9 times 10 to the 5. Okay, so is everyone happy with those questions? Because that's basically how we add and take away in standard form. So if we're okay with these, I'll put the answers into the chat actually, so you can refer to them. Then we'll have a look what we got next here. Because I have got a plenary question, which is quite nice. Yeah, so these are just some general questions. We'll leave those for now. This is a good question. So the mass of 2 of Saturn's moons, so Enceladus and Titan, are 1.1 times 10 to the 20 and 1.4 times 10 to the 23. This is to one significant figure, respectively. We want to work out the total mass of the 2 moons. So what we need to do, well, have a think about it. If you want the total mass, we need to add them up. So has anyone got any ideas how I could do 1.1 times 10 to the 20 plus 1.4 times 10 to the 23? So what we would need to do again is make the powers of 10 the same. So we could take 10 to the 20 and times that by 10 cubed, which is 1,000. And then you'd have to divide 1.1 by 10 cubed. Now, if I do 1.1 and I divide it by 10 cubed, it's going to move the decimal point back 1, 2, 3 places. So you would end up with 0.0011. So you've got 0.0011 times 10 to the 23 plus 1.4 times 10 to the 23, which is going to be 1.4011 times 10 to the 23. So again, I've just added the number parts once the powers of 10 are the same, and that's all you've got to do. And we'll leave B for now, because that's to do with dividing in standard form, which we've done yesterday. Here we go. So we'll do some, I'm going to make some similar questions to what you might have in the test, which is not till half term. So no, not too long now, but not exactly tomorrow. So while I do that, have a think if there's any questions you have, and we'll go through any questions that you've got as well. Let me just find that now. Where is it? Assessment 1. I think that's what it is. Let me just stop sharing my screen for 1 second. That's numeracy. Right, just 1 second, everyone, won't be long. Just want to get some similar questions for you. So, there we go. Right, I'll put this over here. There we go. Okay, right, so let me get word up. Right, so we'll do some similar questions to the ones that you might have. So I'm just going to make these now. I'll do this one. 10 times y minus 3x plus 4x minus 12 and 8 times 4. Right, and this should be a standard form question as well. My gosh, so no, that's fine. And mass. There we go. There we go, that's a good one actually. So, Okay, let's have a look at these questions here. So these are quite good questions to practice with. So for the first bit, we want to expand these brackets. Okay, so we have 3 bracket x plus 5. Does anyone remember how we would expand that bracket from last year? I'll just give you a hint. Remember, this means 3 times the whole bracket x minus 5. So if I want to expand it, I need to do 3 times x, which is 3x. 3 times 5 is 15, and there's a minus in between, so it's minus 15. 3 times minus 15. 3 times minus 5 is minus 15. Okay? So you should be able to do this one and this one, so you can have a go at expanding those. So I'll give you a few minutes just to expand those, and then we'll look at simplifying and the calculation. So have a go at expanding 5x minus 2 and 10x minus 3. Okay, so 5 bracket x minus 2, we should have 5x minus 10. 10 bracket x minus 3, that should be 10x, take away 30. Okay? So if I wanted to simplify these expressions, you would need to expand first. So 10x, and then you've got 10 times minus 4, which is minus 40. So it's 10x, take away 40y, add 12y, take away 13. So you would need to collect like terms. So we know 10x is just 10x. Minus 40 plus 12. What's minus 40 plus 12 going to be? So if you imagine 40 take away 12, that would be 28. So that's minus 28y. And then you're taking away 13. And then the next one, you've got 10y, take away 30x, plus 4x, take away 12. So you've got 10y, and then you've got minus 30x plus 4x. What would that be? So that would be minus 26x, and then you've got minus 12 on the end. Okay? Then lastly, you've got y times y squared, which is y cubed. And then y times minus 4 is minus 4y. So you have y cubed, take away 4y. Okay, so it's very important that you can do all of those. You'll have questions very similar to that in your assessment. And the last question looks really easy because the powers of 10 are already the same. So we would need to do, oh, this is going to be a minus, isn't it? Right, I'm going to change this question. 4.47 times 10 to the 23, take away 4.45 times 10 to the 23. So to do this, the powers of 10 are already the same, right? So you would need to do 4.47, take away 4.45, which is 0.02. So you've got 0.02 times 10 to the 23. Now, is that in standard form? So can someone tell me if that's in standard form or not? So we should know that's not standard form, because standard form is always a times 10 to the n, where a is bigger than 1 but less than 10. So in fact, to make this into standard form, you would need to times the 0.02 by 100. You'd have to move that decimal point 2 places to the right. So if you times 0.02 by 100, to keep everything balanced, what would you have to do to the 10 to the 23? What would you have to do to that part of the number to keep it balanced? Well, what you'd have to do is divide that part by 100. So you'd end up with 2 times, now you've got 10 to the power of 23 divided by 10 to the 100, which is 10 to the 2. So that will give you 10 to the power of 21. So you'd end up with a final answer in standard form of 2 times 10 to the 21. Okay. So have we got any questions there? Has anyone got any questions about the homework? Let me get the homework back up. I think when I set that, did I set that today? Your homework day is Friday, actually, so I'll be setting you homework today. So most of you have done really well on the homework. Most of you. I think all of you here actually have, which is good. Just remember the second homework. So if you haven't finished it yet, it is due, well, I've set it to be due tomorrow. It's this one here. Okay. So I just don't mind picking on Lucy there, but there we go. So yeah, it's only these questions here. There's very little there. Okay, so there's really not much to it. Does anyone want any help with these? There's not much to it, really. Okay, so that's the homework as well. Make sure you finish that. If you are stuck with it, please just message me, and I'd be happy to help. But otherwise, we'll leave it there. Now, I shall definitely be here on Tuesday. Hopefully, if I can come on Monday, I will. I'll try to come on Monday. So thank you for your hard work today. Make sure you finish that homework, and if you've got any questions or anything, please let me know. Okay, thank you for bearing with me this week. I am sorry about not being able to be there.